Welcome to the B&W Camshaft Less engines, MEC engine, electronically controlled engine. So, first module we had discussed the basic concepts of the engine, introduction, and in this module now we'll learn what are the components, electronic components it is an electronic engine, electronically controlled engine. So we'll be using uh, what is called electronic components. All right. So electronic components and networks. I discussed earlier, engine control system consists of controllers called MPCs, multi-purpose controllers. Do you remember them? Can you name them? Yes, EICU, Engine Interface Control Unit, ECU, Engine Control Unit, CCU, Cylinder Control Unit, and ACU, Auxiliary Control Unit. Very good. Control network. For redundancy, two networks are in use, network A and network B. Always available, always standby, as we call them, hot standby. Then we have what is called main operating panel, LOP, local operating panel, TACO system. So together they are part of the engine control system. All right. Now, apart from them, performance measurement of the engine is necessary so that we can make adjustment and change parameters as and when needed. Pneumatic maneuvering system is also exists, which is basically same as MCC engine, but with few necessary changes since there are no puncture valves in ME engines, MEC engine, no air distributor, and it is much simpler. All right. So you have a starting air valve exactly same as conventional engine. Only the pilot air which enters instead of coming from the air distributor, it comes from a solenoid valve. That is the major difference. All other things remain same as in the MCC conventional engine. All right. There are four controllers in use for operating ME-C engine. They are EICU, Engine Interface Control Unit, ECU, Engine Control Unit, CCU, Cylinder Control Unit, ACU, Auxiliary Control Unit. All of them have different functions to carry out, and we will learn about them in different modules. Without learning about them, we cannot operate the engine. We must get ourselves familiarized with function of all of these four controllers. All right. Thank you. All of them are called multi-purpose controller because they are exactly same. They're exactly similar construction hardware wise. The hardware consumption is similar. But the software they use is different. But as I told you, I think for introduction module also, for CCU, they later on adopted a new system, which is simpler version, MPC10 they call it. The cost is reduced and only four functions need to be carried out by CCU. So they are using MPC10. Remember, this multi-purpose controller is different than other multi-purpose controllers. So if you need to replace CCU, you have to use MPC10 in case MPC10 CCUs are in use on your ship. So MPC10 is being used, which is simpler and is different than all other MPCs. Some ships you will find where CCU, the MPC used for CCU is also same as other CCU, other MPC, as for EICU, ECU, and ACU, etc. So this you have to go on the ship. You have to see on your ship. This is done for cost optimization. Keeping in mind the specific function CCU is required to carry out. As far as my information goes, the CCU costs around $7,000 for a MPC10 version, and MPC older version, and which is used for EICU and ECU and ACU is roughly $15,000. So there's a lot of money involved. However, the MPCs carry out different tasks as they are configured to different software. All MPCs are connected to the two control networks, A and B, and also connected to the MOP and LOP. MOP main operating panel, LOP is local operating panel. Backup application and the software which individual MPC uses are stored and available on both the MPCs. Stored and available on both the MPCs, MOP A and MOP B. When there is need to replace an MPC for any reason, it will download the required software from the control network. It uses a different ID key. ID key has to be put in place, then only the MPC will download the software. And this dongle or ID key has a actually pre-written small program which initiates the downloading of the required software for the particular MPC. All right, understood? How does MPC know, being similar in hardware wise, which software to download? Once again, now you answer the question. Because each MPC has to be connected to the control network with an ID key. Yes, which is different for different MPCs like EACU, ECU, CCU, or ACU. Therefore, required software is downloaded as per the ID key of the controller. ID key is also called dongle. Again, ID key has a software written down already. So machine will read only a machine. So that the instruction goes from the dongle key to the software, MOP, and the required software is downloaded. We'll just see a view of the MPC. MPCs are a highly quality product to ensure that reliability in harsh marine environment is met. Therefore, MPCs are placed in an IP66 cabinet. IP is ingress protection. What does IP stand for? Ingress protection. What is the ingress we're talking about? It has got two digits. First digit refers to the solid, that is normally dust particles, and the second digit refers to water particles. So in our case, 66 means the first 6 means enclosure are dust tight. If the environment is dusty or dust is blowing through or available present in the machinery spaces, it will not enter into the cabinet. And second 6 is means protected from water projected in powerful jets from any direction. If a powerful jet is sprayed on the cabinet where ECUs are kept, this water jet will not enter into the cabinet and affect the MPCs. So that is why it is protected, put in a cabinet which is protected by IP66 protection. All right. So this is an MPC. Here you see various components: battery for internal clock, LED indicator, service port for the service engineer, ID key, dip switches, and various fuses. So the battery is internal for the internal clock. It's the same like we have in our desktops or laptop. There is a small battery which keeps the internal clock going. Even when your desktop or computer is shut down for a while, when you restart, it exactly knows what is the date and time. So it's keep running the internal system. Remember, in case you need to replace the battery, your engine must be stopped. Enough you know, if at sea your battery has weakened, some alarm or something, for some reason you know that battery need to be changed. Do not change it when engine is running. When you report, you can replace the battery. This LED indicator. This is LED indicator is self-diagnostic tool. It tells you the status the MPC is in at present. I will just tell you how we find that out. Basically, it gives a different light and on a background. So you know, you read the data. I will just explain. All right. A service port is for the service engineer from the man B&W in case they need to put some, make some changes. ID key. This is the ID key I was saying. Where the dog will be put so that required software can be downloaded. These are another some software dip switcher. You can note down the position. Actually, normally you don't have to play with these dip switches unless required as per or unless mentioned in the manual. So carry out the operation as required. Put this dip switch off, put this dip switch on whenever the instruction will be given in your manual. And there are various MPCs, fuses. In case malfunctioning, this also you can check of the MPC. And there's of course power source. We'll just talk about power source. I will tell you. As was told earlier, MPC 10 are being used for CCU, which are similar but not exactly. This is not MPC 10. This is normal MPC. All right. So this is a schematic diagram of the MPC. You have two power sources A and B. One source is from UPS, uninterrupted power supply. Other is from the battery backup or DC service, DC power. In case your MPC is hanging up or you doubt that MPC is not working, first thing you need to do is put the power off. Remember now, both the power should be put off, like we do in a computer system. Put the power off or put the power on again, like your mobile phone also. But remember, both the power sources must be put off, and then put on again. This is the serial communication port where the MPC will communicate with different parts of the energy engine control system. Service channel is for the authorized service personnel whenever he needs to make some changes. And there are networks. Both MPCs are connected to both the networks. So 24-volt DC insulated power supply with 16 amps breaker is provided. As I said, supply A is from UPS, supply B is from ship power supply. There are various contacts, voltages, analog digital signal, input output, tacho system. There is input and output. Both signals are available, digital also as well as analog, as per the requirement. All right. NPCs are a kind of self-diagnostic tool, as I said. They inform the operator their status through LED lights. So LED provide information either as a constant light or as a flashlight. In fact, MPC sends a coded message through LED lights. Information code and their meanings are available on board. There is information available. So code is to be read as follows. First digit, number of red lights flashing on yellow back or orange background. Second digit, number of green light flashing on yellow or orange background. Two digits will flash with a gap of 1 second. So you can know what is the digit you are getting. 21, 20, 23, 12, whatever. And you read the code in your manual. This. There will be pause of 1 second. Then let's say two digits, twice red will flash. That means it's 2. And then second digits, 3. In this case, it is 3. 2 threes, not 2 1. The incorrectly written. So it's 2 and 3. So 23. We'll correct it. Explanation of the coded message 2 3 actually, not 2 1, 2 3 can be read on the information sheet provided by the maker and is kept on board. For example, above coded message may mean application software is being downloaded or some similar information. All right.